Good morning. My name is Peter Navarra, and I work with Driscoll's Global R&D as an organic agronomist. I've been with Driscoll's for about 3 years now. I've been working in organics for almost a decade, and this is my first conference speaking outside of Driscoll's, and I'm honored to share my perspective with all of you on the future of organic blueberries. I've worked with organic blueberries now in Morocco, Portugal, Spain, more recently in Peru, Central Mexico, and the west coast of California. At Driscoll's, our mission is to continually delight berry consumers through alignment with our customers and our berry growers. And the guiding principles that we use for making our decisions, our values, are passion, humility, and trustworthiness. So, organic farming is not what it seems. We would all love to see the hillside with the sunset and the sheep running through our blueberry fields, but that's just doesn't fit within the current commercial limitations. For instance, food safety does not allow wildlife, sheep, to walk through a production field in conventional fields or organic. The practicalities of running a blueberry business do not currently allow for this ideal, beautiful, utopian organic farm. Although I do believe that that is what the consumer deserves, and we can get there one day. We just have a lot to learn. Unfortunately, organics is a business. It's a commercial business, and it's difficult. For example, in the U.S., we're allowed to use coir to grow our organic blueberries because growing in the soil can be quite complicated. The pest and the disease control in the U.S. is the same as Europe, but we've skipped over the soil health bit because of how complex it is to control. Consumers do get a different product, but not to the nth degree. This may seem crazy, but the price premium makes the extra effort justifiable, and it makes and it drives us, and it gives us that passion for doing the right thing. Now, I see the drivers of the organic movement. I like to think that the future of organic is dependent on the consumer, the regulations, and what's agronomically possible. And the consumer has to care. The consumer has to want organics for it to be around. And there's a long way to go, because less than 1% of the farm ground in the USA is certified organic. Now I'm going to talk about each one of those three drivers. The U.S. organic consumer is, they're 44% of them are purchasing organics because they believe it helps the environment. 75% are purchasing it for health-related reasons. 71% are millennial parents purchasing it for their children. And of all of the organic products available, the one that organic consumers are least likely to purchase as organic is alcohol. Although in 2021, the organic market is up 12%, while non-organic is up 4.9%. That's a big jump over 2020, and we believe that that's related to COVID and people being more health conscious. In contrast a bit is the European consumer. This is a recent survey we did of the European consumer. We have importance on the x-axis, willingness to pay on the y-axis, and what came out in the sweet spot of important and willing to pay was local production and less pesticides. Organic farming just outside that box, however, still important and high willingness to pay. Organic farming has less pesticides, but it's not required to be local. What I found to be interesting in this survey is that sustainability was less important and less willingness to pay than both organic and local, which is interesting because while organic isn't local, it is more sustainable than conventional. This graph is from a 40-year meta-analysis, and they're representing the evaluation of organic and conventional based on 12 metrics of sustainability. And this came from Washington State University in 2016, and what they concluded is yes, organic is more sustainable compared to conventional, but the potential of organic to be sustainable and be better for the environment, to have sheep in the field really, is untapped. Now, if you do look at reduce worker exposure to pesticide and minimize pesticide residues, these petals are much larger than here in conventional. And so when it comes to pesticides, organics is a clear win. Okay, so for regulations, when I speak about regulations, I'm talking about two umbrellas of regulation. The National Organic Program in the USA, which is ran by the USDA, and the European Union, which has their own set of regulations that are then interpreted by each of the member states. The biggest difference between these two is really the the competent authorities within each one. Within the U.S., we work with CCOF for all of North America, while in the EU, the competent authority, and remember this is the organization that interprets the rules, inspects our fields, gives us our certification, and allows us to use that USDA organic label, or the European Commission label. In the EU, our partnerships are regional. In Portugal, we work with Sativa. Morocco, we work with CCPB. Spain, Agrocolor. The Netherlands, we work with SCOL. And then EcoCert covers a lot of different areas. We haven't started working with them yet, but it is available. And then another big one is the difference between the regulation of producing organics in substrate. In the US, yes. In the EU, no, and most other areas don't allow the production of organics in substrate. However, there is an equivalency agreement between the two. So for a while, we've been able to export fruit from the US, organic, grown in substrate, to the EU. I think the EU is tightening up their rules here soon in 2022 on things like that. So maybe not for long. There's others that are interesting, but at the end of the day, the products are fairly similar. Now, I would say there's less of a difference between organics and conventional than there is between organics in the EU and the organics in the US. And when you look at when you go to an organic farm or you go to any berry farm, sometimes it's difficult to tell if you're on a conventional farm or an organic farm. Just from the way that you still see the same diesel tractors, you see the same amount of plastic being used. You see, there's still a risk for nitrate leaching. And when I look at that, I think to myself, okay, a poorly managed organic farm is probably just as environmentally damaging as a poorly managed conventional farm. The managers are the same, the climate, the laborers, the well water, the cooling facility, the sales teams. There's no sheep allowed in conventional. There's no sheep allowed in organics. Food safety, that's the same. So for the most part, they're similar for now. I mean, until I don't know, until the consumer demands it, things will probably continue on to be the same. Okay, so let's look at the agronomy side of what's coming and what's current and what do we have to see for the future. Here's some American supply curves and production regions, and I like this graph because it represents how diverse the climates and regions are that we grow blueberries. We definitely don't grow blueberries everywhere that we could grow blueberries, but we do grow them in quite a few different climates and regions, all the way from northern to southern latitudes. Like I said, blueberries are very well adapted to most regions. They're also very well adapted to organic systems. And because of that, organic and conventional blueberries have similar yields. And especially in California, we have low pest pressure, almost no pest pressure sometimes. Blueberries evolved to prefer the organic nitrogen process, not necessarily nitrogen process, but they evolved to prefer ammonium. And in organics, we're short on nitrate, but we're definitely not short on ammonium. Compared to the other berries, it's definitely the easiest one to grow. So here I have the frequently asked questions, or the most common things that come up when talking about organic blueberry production. I put it all on this one page, and the main thing here is site selection. And I say that if you select the right site, you'll get good yields compared to conventional. And that's a well-drained sandy soil with a pH less than 6. They do very well. I also touch on fertility, pest and disease, and soil health here right after this. So for pest and disease, powdery mildew has become a bigger problem, and I think that maybe it could be even more important as an opportunity going into the future, and finding better solutions for controlling powdery mildew. These pictures down here are from Peru, and in Peru, with the large plantings that they have, if something gets out of control, the acute rise of a disease there isn't just, oh, I have a hot spot in 30 or 40 plants or a row. It's, I have a hot spot in 30 or 40 hectares. So the solutions need to be just as robust. Most of us do a rotation between potassium bicarbonate and sulfur. That seems to work. Oils, I try to avoid oils as much as possible, especially if I don't want to remove the bloom, or if it's hot outside, or if I've just sprayed sulfur within the last 2 weeks. So I try to stay away from oils. But this product here, Oso, the active ingredient is polyoxin D. It is a zinc salt. This product is available now, and it's probably one of our best organic products for fighting powdery mildew, other than sulfur. All right, soil health. There's a lot of potential for soil health, and it's become extremely popular. Everyone wants to talk about soil health. Everyone wants to understand soil health. We have a lot of metrics that you can look at, but none of them can you take a soil sample in, they measure it, and they tell you, yes, next year your yield will go up or it will go down. There's a lot of talk about percent organic matter. I think percent organic matter is great, but we see it all over the board, and I couldn't really tell you that if this year your percent organic matter is 1, and next year it's 2, that's going to give you more yield. It's definitely more complex than that. And currently, the best indicator of soil health is your yield. I think we should, though, integrate the tools that we have to understand the dynamics of our soil, and we can call that soil health for now while we're waiting for something better. So, knowing what your pH and EC is, your soil organic matter, those are super important. And if your pH and EC are right, I would say your soil is healthy. You want to know if you have soil-borne pathogens. You want to plant resistant cultivars to those pathogens, or to any pathogen in your field. And then if it does get out of hand and you end up in trouble, we do have a tool called anaerobic soil disinfestation, which is popular in California as a pre-plant treatment for organic strawberries. And it's really just applying lots of labile carbon and then allowing it to ferment with plastic over the top that keeps the conditions anaerobic. and there's a shift in the microbial population, and due to the release of volatiles and the change in temperature, it reduces the risk of pathogen, or it reduces the populations of pathogens in your soil. And then sanitation, which is, removing the inoculum from the field or preventing the inoculum from ever getting into the field. Organic pH control, it's sulfur burners here in the U.S. I've seen sulfur burners in Morocco and Spain as well, and the process is quite simple. The sulfur burns, combines with water. This is sulfuric acid combined with water, combining with calcium carbonate, which releases calcium sulfate, water, CO2, which it needs to off gas, and a hydrogen ion. That's what reduces the pH. So, if pH goes in at 7.5 through the sulfur burner one time, maybe it comes out at 6.1. At that point, the CO2 is still in solution as carbonic acid. It needs to off gas, which you'll see a little increase in pH. And that's important. If you don't let that CO2 off gas, you'll get a false reading in the fertilizer injection rig, and this will come out as a 5.8, but then it'll immediately shoot up as the CO2 off gases to a 6 or a 6.2, and you'll think there's a gremlin in your system, but you just need that buffer tank to allow the CO2 to go out, and then you can top it up with a concentrate, and that's formed from recirculating a small amount of water through this over and over and over again. And I've seen it becomes inefficient after a while, but I've seen the pH of this get down to 2 or maybe a little bit lower. Organic versus conventional fertility. The fertility targets are similar, just different sources. The plant needs the same amount of nutrients, whether it's organic or conventional. So the budgeting of the products should be about the same. The differences of the sources are the availability, the purity, the cost, and the solubility. A pound or a kilo of organic nitrogen right now in the USA is about $25, while a kilo of conventional nitrogen costs $2.50, so a tenth. But a year ago it was a 30th of the cost. So conventional nitrogen has become more expensive, but it's still a tenth the cost of organic nitrogen, which means it's very important to understand the dynamics of the organic nitrogen in your crop, so you can optimize that and not lose out on the yield from having a nitrogen deficiency or just spending too much money. Key to understanding your nitrogen cycle in the soil is understanding how nitrogen mineralizes. Nitrogen mineralization is dependent on adequate soil moisture and temperature. Around 15 Celsius, mineralization really picks up, and just a little bit of moisture will make that process start. Within the soil, the organic nitrogen is mostly plant unavailable. When it mineralizes, and this is a biological process, right, controlled by temperature, moisture, pH, oxygen content, it turns into an organic nitrogen. The first form that it turns into, these bacteria shoot it out as ammonium. And then the next step is pH dependent. So at a low pH, it would stay as ammonium. So in a blueberry field, in a soil pH of 4 or 5, most of the nitrogen will stay as ammonium, and some of it will convert to nitrate. While at a higher pH, say 7, this ammonium will convert rapidly to nitrate, and this nitrification step is also biological, just a different set of bacteria, Nitrosomonas and Nitrobacter. I did say that pH was important. soil temperature was important, and moisture was important, but the rate for mineralization to happen, but the rate at which nitrogen mineralization happens from your specific fertilizer is dependent on the carbon to nitrogen ratio of the fertilizers that you are applying. And so, this is, here we have days after application and then the percent available. And each one of these increases in how much it's available, the percent availability at different rates. And each one of these has a different carbon to nitrogen ratio, which we can see here. So this is availability after 12 weeks. Some of them are 90% available after 12 weeks, and they have the lowest carbon to nitrogen ratio. So something with a high carbon to nitrogen ratio, lots of carbon, very little nitrogen, mineralizes slowly, like wood or plant composts, or even some manures mineralize slowly, but the liquids, the blood, the feather meal, those mineralize very quickly. Point here is to know what you're applying so that you can know how quickly it's available, and so you can use it as you can manage that resource and optimize your applications. So we just took the most popular sources of fertilizer nitrogen in the US, and we sent those off for analysis. And it was a good thing we did, because we learned quite a bit from doing this process. We learned what was soluble, we learned what wasn't soluble, and we learned that there was some bad stuff in the products that we didn't know about before. For instance, this product here, Vitamin Clear, when I first started in organics 8 years ago, this product was extremely popular and very hard to get. 0 carbon to nitrogen ratio, basically all nitrogen, instantly available. No organic nitrogen, but the total was almost 4. No ammonium. All of the nitrogen was in the nitrate form, and nitrate in organics is really rare. It's hard to get. Unfortunately, it was 20% sodium chloride. So we were just applying a bunch of salt to get that nitrate. Fortunately, later this product came out, Super 6, not long after. Super 6, very low salt, 6% total nitrogen, and almost all of it was already available as ammonia. So this is a fantastic product, and there's others like it, but they're hard to get. That's the problem, and they're expensive. Here's a product, AgroThrive LFP and Eco 511. One's in red and one's in green. They're both fish emulsions, and they're both fairly low in, this one's much lower in salt than this one is, but this isn't crazy high, but this is better. The difference is with fish emulsions in the US, we're allowed to stabilize those with either phosphoric acid, citric acid, or sulfuric acid. Since there's so much sulfuric acid already in other organic fertilizers like sulfate of potash, and already in our soils and in our water, we try to eliminate sulfur from our recipes. So this product here, Eco 511, it's stabilized with sulfuric acid, which if you needed sulfuric acid, that's great. Or if you needed sulfur in your crop, that's great. But since we don't, we've got so much of it available in other forms, we have this one in red. AgroThrive LFP is stabilized with phosphoric acid, so it's a soluble form of phosphorus that we can apply and not have to worry about phosphorus. Now, those fish emulsions aren't available, not available in Europe. The phosphoric acid loophole is just available in the US, so sorry about that. Okay, here's a little dive into one of our regions of the Pacific Northwest. It's where the majority of Driscoll's organic production is coming from for the US. And this is just such a beautiful ranch, and you can see the furrow cover crop with the flowers and the blue sky, and I can just see it. I can see sheep running through this field, and it would be the perfect, organic farm with animals and plants and humans all living in harmony. And the blueberries look great too. So I would like to talk about nitrogen on this farm. So I found an uptake curve based on a 20-ton per hectare yield. And I've also got down here, I've got down here soil temp to show you that, yes, this during the entire time of these growth periods, the fruiting, all the fruiting is here. During the entire time here, the temperature, the soil temp is above 15 Celsius, which means that there's always mineralization going on. So we're not going to be cut off by starting about right here. The temperature is warm enough for mineralization to start. So there's really no point to apply it before then, because if there's a rain event, you're just gonna lose it during this period of the year. So it's good to start applying now when the growth starts. Apply through the fruiting, through the root growth, and then stop in September. So all of your nitrogen would come on here and then stop about right there. Now, I don't just look at something like this and say, oh yeah, you always need the same amount of nitrogen. I like to look at, well, how much organic matter is there? Because some of that mineralizes. And how much is already residual in the soil? Because that's in the bank. So I do like to look at the soil sample. And this is such an interesting soil sample to me because the organic matter is 2.6%, which is wonderful. We would normally say, wow, that's quite an advantage to have 2.6%. But I've seen in this region 14%. I've heard about 18%. And it's fascinating because the exchange capacity here with 2.6% is 30, and the exchange at 14% was like 25 or something. And in substrate, the organic matter is 100%, and the exchange is probably 100 as well. And it's just so much air, and it's just such a better environment. And this is about as good as soil is going to get. So it just goes to show again what an advantage substrate is. Anyway, there's not much nitrogen or ammonium here in the soil, but that's to be expected in an organic farm. You wouldn't normally see high levels of mineralized nutrients because they're going to constantly either be taken by the plant or in the body of a microbe or just in low levels because there's no conventional highly soluble forms going in. All right, Central Mexico. This region has really low harvest cost, which creates an opportunity for high flavor varieties. They can support varieties like Arana that have a little bit lower yield, but have amazing flavor. I hope, this is what we pack into Sweetest Batch and starting about right now. And I hope all of you get to try Arana because it is Arana from Central Mexico because it is delicious. Now, Central Mexico does struggle with heavy soils, which is what's driven them to substrate production. Here's California, substrate and soil, organic Ceres here. These farms are both right next to each other, and I visit them frequently. And this farm has just done very well. And I think there is opportunity for there's opportunity for organic plantings and soil in California, definitely in this area as well. But these got planted into what looked like sandy soil, but it just didn't drain well. It had a clay pan, and the water just kind of stagnated. And these have not done very well at all. If they get 5 tons per hectare, that would be incredible. So there's challenges there in California, but the main challenge in California is the high cost of labor. And in Southern California right now, there's a giant whitefly that's becoming a nuisance in blueberries. Peru has low harvest cost, low non-harvest cost. It's open air, and very high yields. It's not uncommon to hear 40 tons per hectare in Peru, and the scale is overwhelming. In the last 10 years, they've planted 15,000 hectares, and half of those plants are mature. Over 10% of the volume is already organic, and that's going to keep increasing. When I was down there, I went to an 800 hectare organic farm, and they had actually, I think it was planted in 2017. and they had lost 200 hectares of it to mealybug and had to convert that to conventional. It was just mind blowing that you could. It was probably the largest organic blueberry farm in the world. And when I look at this, they really are big. You can all the way up to this mountain. That's blueberries. It's really it's like a whole nother world down there. And lots of water, lots of space, lots of labor. If the next 10 years looks like the last 10 years, then global blueberry markets and strategies will have to change. I didn't forget about Portugal. Organic is definitely an opportunity in Portugal. I think in these three regions for sure, open air plantings, maybe even in tunnels here in Southwest Alentejo. The moderate climate versus the northern Eastern European countries with the harsh winter weather. It's a big plus for Portugal. There's a long production period throughout the year, and it just allows for labor and resource management that make this an opportunity for local production, which seems like that would be a win for the European consumer. But more importantly, back to the sheep. Some consumers only buy organics, so I feel like they deserve to have sheep in their field. Unfortunately, organics is competing in a very complex marketplace. It is a premium product that does cost more, and we do have a higher revenue. But we're also, as a company, we're going after better flavor, bigger size, the sweetest batch label, and organics must fight its way up this list of priorities. And I think that to do the right thing by the consumer, it comes back to our values. That's trustworthiness on our side, and passion because of how difficult it is, and humility because we have a lot to learn about it. So that's my take, and thank you for your time.